Hi there. In this tutorial I'm going to demonstrate how to create some text and then crumble and shatter it like this. We're going to use an add-on called Cell Fracture, and there's a few little things to be aware of, especially when using it to do effects that are derived from text. So to begin with, we'll just create some text. So we're going to add some text here. I'm going to rotate on the X 90 so we can see it, and we'll scale it up a bit for our purposes. And we'll just change it to what we want. One of the first things you may want to do is alter the font used for that text. So if we come down here, you can see we have some options, and under here we can change the font. So if we go to your Windows, if you're using a Windows PC font directory, we can pick whatever font we want to use. Now, one thing I would say is for some steps that come next, you're better off sticking with a simpler rather than a very, very complex font. So the more rounded ones without the serifs, which is these little bits on the end here, are going to be easier to work with. You can do it with any font, it's just the amount of work that there is to make it work with the add-on. So we'll go with this nice blocky font here, and we would also normally want to extrude that, which we can do in the geometry space, obviously to give us a solid block of text. However, we don't want to do that at the moment, because one of the problems of the text creation within Blender, which uses curves, is it creates quite a complicated, messy geometry, which causes us problems later on. So in fact, what I will do is demonstrate that. So I'm going to make a copy of my text, just put that over there. We'll come back to here and we'll extrude it, and then we'll press F3 and we'll say convert to, and then we'll say mesh from curve object, because text is basically a curve object. So nothing appears to have changed, but if we go into edit mode, you can see this is now a mesh. And you can also see it's quite an untidy mesh, and there's worse in there than that. Some of these vertices, as you can see, aren't properly manifold, as it's termed. Now there are some things you can do about that if you're already at this point, but let's just have a look what happens if we now apply our fracture modifier. So this is now under quick effects, and you should be able to see Cell Fracture. This used to be an add-on in earlier versions of Blender. So we'll just click Cell Fracture and we'll accept all the defaults. And you can see it sort of builds up a fracture around it, and then it spends some time thinking about it. Now the first thing you can see is that it hasn't finished. In fact, our original mesh is still in there. There it is. I can pull that out, and I'll delete that now. And you can see it started to create a fractured version of our mesh, but there are still these lumps here. And if I take that away, you can see there is no fractured version of our mesh behind it. I can take that one away and so on. So it's made a bit of a mess of that. And the reason for that is because of problems with the geometry. So we'll do it slightly differently this time. The less geometry there is to work on, the easier the next step is going to be. So at the moment, this is a curve object. You can see if we go into edit mode, it just takes us into editing the text. So we do want to convert that, but we haven't added any extrude on it as yet. So we'll just press F3 and we'll say convert to mesh from curve. Now we've still got that problem geometry, but there's a lot less of it for us to deal with. There's only one face here at the moment. So what we're going to do is we're going to select everything, and then under mesh, we'll say clean up and we'll say merge by distance. And you may find it doesn't do anything to start with, and you just need to increase this number, and you can see something happen there. And all this is doing is if a vertex is very, very close to another vertex, then it will just churn them into one vertex between them. And we can go a bit high, and you can see that's too high now. So I'll go Control Z on that, and we'll just go back down to 0.01. And that's already improved it. It's not great geometry, but it's better than it was. Now we could probably work with that. You can see by selecting some of these vertices, there aren't any hidden vertices in there because we've merged nearby ones. But the best thing to do is to clean it up a bit more than this. So we'll start by going to face select, and we'll just select a lot of these faces here. It's probably best not to select all of them, especially on a very curvy face like this, although it is theoretically possible. And then press X and say dissolve faces. You can see we've got one up there, so I'm going to press Control plus, and that's just expanded the selection a bit, and then dissolve faces again. And then I can just select these down here and I'll unselect that top one. I use Ctrl+ again there and press X and dissolve faces. And we need to do that with all of the others. So it is a bit of extra work, but it will save you a lot of heartache later on. So having done that, you can see we've got a much more simple geometry now. So I'll go into edit mode, select all the vertices, remembering this is a mesh now, press E and then GY just to extrude that out a little bit. Because we've got some thickness. So that should be much easier for the cell fracture to work on. So let's try that now. Before we do it, let's apply the scale. And then we'll go to Object, Quick Effects, Cell Fracture, and we'll just accept the defaults. And you can see that was much quicker, and for the most part, it seems to have worked fine. Occasionally you will still get an error. I'll just select the original text and just move that away, and you can see we do have a couple of missing parts in there, and if we Ctrl Z we can backtrack, and if we have a look we may have some more complex geometry just there, and indeed we have. You can see there's a slight issue here, so what I'll do is I'll rectify that. So I'm going to select this edge and delete that edge, and we'll need to do the same to the one at the back as well. And now I'm just going to change the geometry by just joining those up there, and then from the same side on the other side. And now I can just select all the vertices in this ring, and again all those around here, just up to the point within this boundary. Make sure we've got them all selected, press F, and that will recreate that base. And in fact, I think I'm going to make it simpler than that. At this point I'm going to remove those two edges and then rejoin those two. So I've now created a polygon there, and the same on the other side, and then just fill that one back in again. We've now got much more sensible geometry. We might get some problems up here possibly, but let's have a look at how that's doing. For some things you can just repair them yourselves, but the lesson there is make sure the geometry is very simple and you haven't got any internal faces or anything like that. You can use the 3D printing tools to help you there. So if we say check all here, you can see there are no non-manifold edges or anything like that. There are some intersecting faces, and those may be the ones where we have some problems. And if we just click that, it will actually show us where they are. So there's actually some intersecting faces here. It doesn't look like it's too much of a problem. So even though it's for 3D printing, that can be quite useful for this purpose. So we'll go up to Object and say Quick Effects and Cell Fracture, and again we'll accept the defaults, and it's just finishing off. And if I select my original mesh, that looks pretty good this time. So I'll just undo it, and then we'll talk about some of the options in there. So you get this little window up, and it essentially creates particles and then fractures the object around them. I'm not going to go into a lot of detail with this at the moment, but it's quite a powerful add-on. You can specify where you want the fracturing to occur with things like the grease pencil. So you can use that to draw on a flat plane to perhaps create a sort of bullet hole in something, or a shattered mirror, or whatever you want to do with it. Recursion is where it will break a shard and then break the shard again. Don't want to go too high on that, otherwise it will take a very long time and probably crash. It is a bit sensitive to crashing. Obviously you can set the number of particles here. If you go too high, then you're just going to end up with little more than dust. And obviously you can put some noise on it just to create some variation, and that's fine. I'm going to stick with 100 particles. That's fine for our purposes. You can limit the recursion here, by the way, at 250. And you can say whether you want small, big, or for that matter, random size particles. I'm going to just stick with small. One of the things you may want to do is have a different material on the inside. So before we use that, let's apply some materials. So let's just have a basically green material, make it a little darker than that for the outside. We'll call that outside. And then I'll say a new material and we'll call that inside. And we'll make that a nice orangey color, because obviously once it's fractured, we're going to have new faces created and we're going to see what's inside this text. So we therefore need to know what material it's going to be. It could be the same material, but it can be quite interesting to have a different material. So we'll go to Object now, Quick Effect, Cell Fracture, and then under here you can see it's saying Material 0, which is the first material. If I change that to Material 1, it will now use the second material for the inside. Margin is how much of a gap you want between each fractured piece. Now we are going to use physics for this, so it's actually a good idea to have a slight gap. We'll actually put a very small one in there like that. Obviously it's more visible. If you really don't want the fractures to show before your mesh actually breaks, you can do some fancy things like swapping in the original unbroken mesh in video effects and then replacing it with the shattered version just as it begins to shatter. But for this one, we're not exploding the whole thing all at once. And that was part of this tutorial, is to say this mesh is going to split up in a sequential way rather than just exploding all in one go. And we'll get into the physics on that in a moment. And we'll say OK and see how that does. I did find if you use too big a margin, you'll start to lose chunks. So that looks pretty good. We'll just move this out of the way for the moment. And there is our mesh. And if I move this particle out, you can see that there is a new material on the inside. So we go to rendered view. I'm going to just add a simple sun lamp into the scene just so that we can see what's going on, and we'll set the background to black. So there is our fractured text, and we now need it to do something, because if we press play now, nothing happens. So how do we get this to animate? So I'm going to go to wireframe mode and I'm going to select all of my text, and you'll notice normally one of the chunks will be a lighter color of orange than the others. If there isn't, just click one of them. As long as you can remember which one it is, then that's fine. This is going to be the one that we initially set all of our physics properties for and then copy to the others. So we'll come to here, which is physics properties, and we'll say rigid body. It's an active rigid body. It's dynamic. It's not animated. We would need to select animated if there was something going on in animation terms with our text before we added our rigid body. Convex hull is probably not the best thing to use because this is an odd shape. Convex hull will just sort of select pretty much a sphere around it. So we need to set this to mesh, and this will now use the actual shape of this fragment to determine the physics properties in terms of collisions and things like that. Everything else will leave the same at the moment, but we now need to press F3 and say copy rigid body settings. And what that should have done is copied these rigid body settings, these physics settings, to all of the other particles that were selected. If I select one of them, you can see it's got the same physics. So if we press play now, you can see it all just shatters and falls down, which might be what you want. But if you want something a bit more the way I did it, then one of the things to do is to work on the gravity. So if we come to the scene properties, and you can see one of the options here is gravity. I'll unclick gravity and press play, and you can see we still have the thing exploding, but it's no longer falling down. So that has removed gravity from the physics system. So that's step one. We'll now open up the rigid body settings. I'll go back to solid view at this point, and we'll also change to EV mode just to make rendering a bit quicker. And we can look at the settings in here. So one of the things I did was I slowed the whole system down. So let's go to 0.5 for the speed. It's still going to do exactly as it was doing, but it does it over more frames now. You can see it's just exploding, and that's because the particles are very close together, and also it'll be to do with how many calculations per second are being carried out. So at the moment the default is 60, so let's try 120, and you can see it still shatters. Now one of the things that we also need to do is we need things to not be moving straight away. Very often there's a little jiggle as soon as a physics simulation starts, and with something like this, that because they are so close, that's enough to get them moving already. And also we'll probably have a collision margin around each of these objects. So if we make sure we've got one of them selected like this, we'll go to physics properties and we'll open up sensitivity, and you can see it's 0.04. You really don't want it at 0, but let's try going for 0.01. See if that makes any difference. I'm not fully expecting it to, but let's see what changes. And at the moment, of course, we've only affected that one. So we need to go to F3 again and copy rigid body settings. And you can see it was a little bit less willing to explode. It still did. So let's go for 0.001. And again, copy the settings. And you can see now some of them are not even exploding. What's happening is we're getting a few shooting off and then hitting others, and there's a sort of chain reaction. So that's quite nice as far as it goes anyway. So if we look at this S over here, this actually is stable until some of the particles from over here. It's almost a chain reaction. In fact, it's exactly what it is, a chain reaction. So that's quite fun. But how can we make it more completely stable until something else happens to it? So that's pretty close. We'll go with a margin of 0.001 at the moment. Clearly it's not quite enough, but rather than trying to balance things, if we come down to dynamics down here and click deactivation and open that one up and click start deactivated, you can see we've still got a few causing a problem down here. Basically what this will do is if the velocity or angular velocity, how fast something is spinning, is below these points, meters per second, the object will just stop. It will be assumed to be essentially stationary. But we may still have a problem with the margin up here. So go to 0.0005 this time. Even that is still too much. There's obviously an issue in a couple of the letters here. So we've got a margin of 0.001 and we said start deactivated. And I've pressed F3 and copy rigid body settings. So they've all got that. That's one you'll often forget, and that's important. Now when I press play, nothing happens, which is what we want. So it's in balance. Every one of those things have got physics properties and are disconnected from each other, but there's no force to cause it to break apart at the moment. So now what we can do is actually add a force. So Shift A and add under force field, just force here. If I press play now, suddenly it starts breaking apart again. And that's because this force is affecting it already. Now we'll start with the values I used, but again, this is such a fine balance that you'll always need to adjust things. So we'll go for a very low strength, 0.001, and you can see it's still affecting it at the moment. And then we'll come down here under fall off and we'll say use maximum. So this will define the point at which the force has no effect. So I've just pressed use maximum, it's 0 meters at the moment. So now what I can do is increase this number, and you can see there's a little circle just here that shows you where the force will have no effect. So if I look from above, you can see we haven't reached this point yet. So I'm actually going to leave that at a very small number. We'll say 0.1, so it's only there. But if I now put this very close, see it's not quite there yet, I'll now put it so it's close enough to actually touch, as it were, the text. And we may need to increase the size a bit. There we go. And that immediately kicks it off. Again, it's finding where it will start to affect things. And I have found it to be extremely sensitive, and strictly that force shouldn't be affecting this letter over here yet. But there's always a bug or two hiding in there. And the other side of it is that the rigid body system will need to be decached, as it were. So in other words, it will create a cache the first time you do something, and then it needs to be convinced to rewrite that cache. If we come up here and just change the speed or something like that so that it recalculates. Now while we're in here, let's put these steps per second up. Let's try 120 now. And you can see again we're getting this chain reaction. So one of the other things I need to do is look at damping. Come back to that force and we'll go back to 0.1. So you can see here when the force is here, it doesn't have any effect at all. By the time it gets to about here, maybe slightly closer, it's now having an effect. It seems to affect some particles more quickly than others, and that's just one of the weird things about the way these forces work. So what I'll do at this point is I'll move my force field to there and press I and select location. Then we'll go to the end of the animation and put my force field somewhere like that. Press I and say location. And I'm going to right click there and just say interpolation mode linear. So if I press play now, you can see the force moves across, and as it does so, it starts to kick off the disintegration of the text. Now if you want to reduce a certain amount of the continued movement of the text, in other words, so that things don't go just flying off, what we need to do is put some damping on it. So the default damping is very, very small. But what I did increase was the rotational damping. So I went up to 0.5 on that. So things didn't keep spinning quite so much. But you can increase the translation damping, in other words, how fast things shoot off and how they slow down over time. So let's have a look at that. You can see it's so small it actually doesn't affect all of the particles straight away. Some of these, for whatever reason, are not really being affected by the force. We can change the curve of the fall off here. So I'm going to put a power of 10 there. And you can see it's still affecting it. And if you didn't want to use a force, you could certainly use another mesh. And if you wanted to, you could set that to invisible. If you're having to reselect meshes a lot like this, one of the ways to make it a bit easier is to actually put them in their own collection. So if I press M and say new collection, and you could say fragments. If I unselect everything now, you can just come up to here and you can say select objects. And just remember to select one particular object that you're then going to adjust. But don't forget to copy all your settings over. And really, that's all there is to it. By having that, using a force, it's something that's invisible. You can try different forces. If you're going to turn this into an animation rather than a still scene, I suggest using a little bit of depth of field. That'll make things more interesting. And a moving camera is good too. So I hope you found that interesting. If you did, let me know. And I'll see you in the next tutorial. Thanks a lot. So I hope you found that interesting. If you did, let me know. If you enjoy these tutorials, don't forget to click like and subscribe. I also have a Facebook page and a Twitter account, and I now have a Patreon page as well. And I'll provide links to all of those in the description below. So I'll see you in the next tutorial. Thanks a lot.